All right, y'all. We are looking right now at the second section of our Topic 11 notes. And today we are talking about exactly two things. Thing number one is the circumference of a circle, and thing number two is the area of a circle. Okay, so actually, before we talk about either of those things, I want to mention this guy right here, pi. Okay, pi is something that you have heard of. Pi is a number that you've been using, and it's equal to about 3.14. Okay, and I want to make that very clear from the very beginning that pi is not a variable. Okay, pi is a number, it is a constant number that is equal to about 3.14. So, whenever you see pi as part of your equation, part of your formula, whatever it is, you need to make sure that you are treating it the same way you would treat like the number 2 or the same way you would treat the number 28. Okay, it is just a number. Okay, you can multiply and divide, add and subtract just like anything else. Okay, so with that in mind, let's look at what pi is relative to circles. When we talk about circles, pi, this is the first thing that you're going to write down on your notes, is equal to the circumference. That's what I'm gonna go ahead. It's C over D, but I'm gonna go ahead and complete those words. Circumference divided by diameter. Okay, the diameter we already talked about in the vocabulary words, but the circumference is something that we're going to address today. The circumference of a circle is the fancy word for the perimeter. Okay, the perimeter of a circle. The reason we have its own name is because on every other shape, when you find the perimeter, you just add up the side lengths. Well, you look at a circle, how are you going to add up the lengths of sides on a circle? It's completely round. Okay, so that's the reason it has its own name, is because it has its own way of calculating that perimeter that's different from every other shape. Um, we are also going to be dealing with that term, the diameter. Okay, and the diameter in this last little picture right here shows you the relationship between the diameter and radius. And we talked about this a little bit on our vocabulary terms, that the diameter is a line segment that goes from one side of the circle straight across through the middle all the way to the other side of the circle. Okay, the two endpoints are on the circle, but it crosses through the middle. Now, the radius, as we described it, was another line segment, but instead of going all the way across, the endpoints of the radius were one on the circle, and one of them was the center. And so, when you've drawn a diameter on a circle, you've actually drawn two radii, and that gives us this relationship where the radius is half the length of the diameter, and the diameter is doubly as long as the radius. That's going to be some important information here in just a little while. Okay, so let's first look at the formulas for these two things, circumference and area. And circumference is one, you probably learned both of these at least a little bit in middle school. And the way you learned about circumference back then was this formula right here, pi times the diameter. Okay, that's a perfectly reasonable, perfectly good way to learn about the circumference, because it's true. Pi times the diameter equals the circumference. But we are also going to be using this formula today, 2 times pi times the radius. Okay, and the reason we're going to be using this one is because a lot of times something on the circle is related specifically to the radius and not the diameter. But we also know, because of this relationship right here between the radius and diameter, we can figure out that this 2 times r in this version of the formula, 2 times r is the same thing as d. So these two formulas are saying exactly the same number. Okay, 2 times pi times r equals pi times d. It's all the same stuff. Okay, so our other formula is going to be for the area of a circle, and that is pi times the radius squared. Okay, we're going to talk specifically about this, but something that I want you to go ahead and rewrite. You can write it as pi times r squared just like that, but something that I'm going to have you do is also write it like this: pi, and then open a set of parentheses for the r squared. Okay, and there's a reason we're going to look at it that way here in just a second. You'll see. So our first problem, we've got those formulas given up top. It says to find the circumference, find the area of this given circle right here. Okay, so first of all, we ask ourselves a question. This 4.5, what is that right there? And that 4.5, the answer, that 4.5 is the radius of this circle. Okay, it's the distance in between the center and the edge of that circle. That is the radius, 4.5. So whenever we're doing any of these calculations, we need to remember r equals 4.5. Okay, so when we're plugging stuff into these formulas, I'm looking at this formula for circumference right here, 2 times pi times the radius, because we already have the radius right there, right? So we're just going to plug that in. 2 times pi times 4.5. It's the radius. So when we have that right there, something that we're going to want to do, and there's a bunch of different reasons for this, but the main one is that a lot of times your answers can be presented in multiple ways. Okay, what we want to do is we want to multiply all of the other numbers other than pi. Okay, whatever else is going on in the formula outside of pi, that's what we want to deal with first. So you can see that this is 2 times pi times 4.5. It doesn't matter what order you put numbers in to multiply them. So we're going to do 2 times 4.5 first, and that gives us 9. We're going to leave that pi alone here for just a second. I want to tell y'all something about this, okay? This right here, if we did not do any other work past that, 9 pi would be a perfectly acceptable answer. And in fact, on your Canvas problems, some of the answer choices will be given in terms of pi. It will just have all of the other numbers put together, however they go, and pi left there by itself. Okay, so 9 pi would be a perfectly good answer. But if you've got a calculator and you can get a decimal approximation for pi, 3.14, you can go ahead and plug that in. Okay, so either of these two answers would be perfectly acceptable. Either of those two things would be correct answers. Okay, 9 times pi, and 28.26 are the same thing. They both represent the circumference around the edge of this circle. The only difference is that this one is left with pi. This one did not deal with pi, just left pi alone. That's what we call leaving it in terms of pi. And this one went ahead and multiplied it all out and got a decimal approximate answer. Okay, we're going to do, to find the area of this circle, a very, very similar process. Okay, if we're finding the area of a circle, we're using this formula now, pi times the radius squared. And let me show you what usually happens. Okay, a lot of times you will look at this expression and say pi times 4.5 squared. Somebody is going to take their calculator and do 4.5 times pi. They're going to take whatever that number is and square it. Y'all, this is not correct. That is all completely false. Okay? When you look at this formula, and there's a reason we rewrote it this way, it was to emphasize that this exponent 2 is only attached to the radius. It's not attached to pi. Okay? So when we talk about doing stuff and dealing with all of the other numbers first before pi, that is another reason to do that, is to make sure you are only squaring this radius. Now, when we do that, we know that we can look in the calculator and see that 4.5 squared is 20.25. And again, this right here, all by itself, this alone is an acceptable answer, 20.25 pi. It is possible on your Canvas problems that your answer could be presented as 20.25 pi. But if you've got the calculator, you can multiply that 3.14. It's easy enough to get this decimal answer also, okay? Y'all need to be prepared to answer in either one of those fashions, okay? It just depends on what answer choices they give you. That's all it depends on. All right? So that's what we got on the first problem. Take a look, flip over the page, look at the next one. So this time, the problem tells us that the circumference of this circle is 25.13. Okay, so this is a circumference problem. We're going to be using these formulas up here. We're not going to bother with anything down here. Let's see if I can fix that a little bit. There we go. We're going to be doing these formulas up here. Circumference, we're not going to worry about the area. So the circumference of this circle is 25.13. So let's start with that equation, the formula itself. The circumference equals 2 times pi times the radius. Okay, we need to ask ourselves, what did this problem give us to start with? And what it gave us is the circumference. It gave us c. This 25.13, that's the left side of your equation right there. 25.13 equals 2 times pi times the radius. Now we are looking for the radius. Okay, that's the item that we are trying to find right here, the radius. So look at the right side of the equation. Look at what's happening. We've got 2 times pi times r. Everything that's happening to r is multiplication. It's being multiplied times 2 and times pi. So how do you undo that? The answer is you divide by 2 and you divide by pi. On the right side of that equation, it all disappears. The 2 goes away, the pi goes away. You have just r all by itself, which is what we were going for. Okay? This is a good time to pull out a calculator. 25.13 divided by 2 pi. Y'all don't forget, pi is just a number. It's not a variable. It's always the same value, 3.14. So if you're doing 2 times that, you could just do 25.13 divided by 6.28. Now, depending on how your calculator, how you punch stuff into your calculator, you could get some little bit varying answers, but mostly it's going to be something pretty close to about 4. We've got a radius of roughly 4 on this circle. Now let's go on to the last problem here. This one is going to be an area problem. We're going to be using this formula right here. We're not going to bother with any of this stuff up here. Okay, so the area of circle F is 75.54. It's asking, what is the diameter? Now, you may look at this and say to yourself, self? That does not make any sense. How in the world am I supposed to find the diameter when the only thing going on in this formula is a radius? There's no d in that formula, it's only r. Okay, and so the answer is way back over here. Y'all, we already know there's a relationship between the diameter and the radius. If you have the radius, you can just double it and get the diameter. Or if you have the diameter, you cut it in half and get the radius. So if we can use this formula and find what the radius is, it's not that much of a stretch to find the diameter. You just have to double it, okay? So that's what we're going to do. It gave us, in this equation, the area. Area equals pi times r squared. And so we have, once again, the left side of the equation. Well, we look at this thing and we're trying to get r by itself, okay? The goal here is to get r so that eventually we can get the diameter also. Okay, so we start by trying to find r, and we look at all the stuff happening to r on the right side of this equation. It's being squared, it's being multiplied. Okay, so we start off, we got to get this r completely by itself, so we need to get rid of this pi. We need to get rid of that multiplying coefficient out in front, so we divide by pi on both sides. Okay, 78.54 divided by 3.14 gives us 25 equals r squared. After the pi's over here cancel out, we got 25 equals r squared. So the question, how do you undo squaring something? Y'all, we have done so many problems. There have been so many cases where I've asked that exact question. How do you undo squaring something? You take the square root. On both sides, you take the square root. That gives you r by itself equals the square root of 25. Now, that's not very difficult to find, right? We know that the square root of 25 is 5. So if the radius is 5, we're not finished with this question yet, because this question is asking, what is the diameter? We have to take that radius, multiply it times 2. That's where we get the diameter. Okay? On your Canvas problems, every single one of them is just like these problems we did in the notes. All of them are just like this, where it gives you part of the circle and you have to, where it could give you the diameter. Maybe it gives you the diameter and asks you what the circumference is. Maybe it gives you the radius and it asks you what is the area. Maybe it gives you the circumference and asks you what the radius is, or asks you what the diameter is. Okay, it's all just working with these two equations right here, working with these formulas. That's what you're going to be using these formulas as equations and solving for whatever part is missing. All right, so that's all we've got for today. Y'all have a good one.